Welcome to Grade 8 Science class. Let's talk about law of acceleration. Law of acceleration states that, when there is a net force applied on an object, the object will accelerate with the same direction of the net force applied. In second and third, law of acceleration also states that, the rate of acceleration depends on the object's mass and the amount of force applied on it. For example, if you push a 50 kilogram object and a 10 kilogram object at the same time, with the same amount of force applied, which will move faster? The 10 kilogram object will move faster, while the 50 kilogram object needs more force in order to move as fast as the 10 kilogram object. This can be explained by the equation, force is equal to mass times acceleration, wherein F is force with Newton as the unit, m is mass with kilogram as a unit, and a as acceleration with meter per second square as a unit. The formula of force is equal to mass times acceleration. Mass is equal to force divided by acceleration, and acceleration is equal to force divided by mass. Now, how did we derive the formula, or where did the formula came from? In deriving the formula for mass and acceleration, use the formula of force. To derive the formula of acceleration, divide both sides by mass. On the left side, since mass times acceleration is divided by mass, mass in the numerator and denominator will be crashed out or cancelled, leaving the acceleration alone on the left side. This gives us for the formula of acceleration, which is acceleration is equal to force divided by the mass. This formula explains that, the more force applied to the object, the faster the object will move. To get the formula for mass using the force equation, divide both sides by acceleration. On the left side, since mass times acceleration is divided by acceleration, both acceleration in numerator and denominator will be crashed out or cancelled, which leaves the mass on the left side alone. This will give us the formula. Mass is equal to force divided by acceleration. This equation explains that the heavier the object, the more force is needed to apply in order to accelerate. Now, remember the following formulas and their units. Example problem. An object has a mass of 30 kg and accelerates at 15 meter per second squared. How much force is applied? In solving a problem, don't forget to write the given formula and the solution. What are the given in the problem? If you read the problem once again, the first given is the mass, which is the 30 kg. Then the acceleration, which is 15 meter per second squared. And the one missing or being asked is the force. Since the force is being asked in the problem, we used the formula of force, which is force is equal to mass times acceleration. In the solution, we distribute the given to the formula. Force is equal to mass, which is 30 kg, times acceleration, which is 15 meter per second squared. Basically, you just have to multiply 30 and 15. This will lead us to the answer. 450 kg meter per second square are 450 Newton. Where did we get kilogram meter per second squared? Well, you just have to copy this and this. Kilogram meter per second square is equal to Newton. Newton is the unit used for force. Another example problem. A person uses 130 Newton of force to accelerate an object to 32 meter per second squared. How much does the object weighs? The givens are force, which is 130 Newton, acceleration, which is 32 meter per second squared, and the missing in the problem, or the one being asked, is the object's weight or mass. Since the object's mass is being asked, we use the formula. Mass is equal to force divided by acceleration. In solution, we distribute the given. Mass is equal to force, which is 130 Newton, divided by the acceleration, which is 32 meter per second squared. Basically, you just have to divide 130 and 32. This will lead us to the answer. 4.0625 kg or 4.06 kg. We round off the answer to the second decimal point. The second decimal point is 6. Since the next number to 6 is 2, we did not add 1. But let us take for example the next number to 6 is 5 above. The answer would not be 4.06, rather 4.07. Now, the answer is in kilogram because it is the unit for mass. But also if we simplify the equation, Newton is also equal to kilogram meter per second squared, shown in the equation a while ago. If we change the Newton to kilogram meter per second squared, the equation would be, mass is equal to 130 kilogram meter per second squared divided by 32 meter per second squared. Meter per second in both numerator and denominator will be crashed out or cancelled. That's why we get the answer with kilogram as a unit. Another example, how fast does an object moves, if it uses 35,000 Newton, weighing 500 kilogram? The given are, acceleration as the missing or being asked, force which is 35,000 Newton L, and mass which is 500 kilogram. Since the missing or one being asked is the acceleration, we use the formula, acceleration is equal to force divided by mass. In the solution, we distribute the given, acceleration is equal to force which is 35,000 Newton, divided by mass which is 500 kilogram. You just have to divide 35,000 and 500. This will lead us to the answer, 70 meter per second squared. We use meter per second squared because it is the unit for acceleration. But the same is what we did a while ago with the problem about the mass. Newton is also equal to kilogram meter per second squared. If we changed Newton to kilogram meter per second squared, the equation would be, acceleration is equal to 35,000 kilogram meter per second squared, divided by 500 kilogram. Kilogram in both numerator and denominator will be crashed out or cancelled, giving us the answer with the unit meter per second squared. For more grade 5 to science lessons, click the subscribe button below.